So, I'm going to talk about Honeycomb. Honeycomb is a framework for writing honeypots and distributing them. Before I talk about Honeycomb in depth, I will say a few words about Symmetria, the company I work at. So we do cyber deception. That means we try to deceive attackers. Our focus is catching attackers while they are doing lateral movement inside the organizational network, also on the cloud. We do that by spreading breadcrumbs on the endpoints in the organization, and the breadcrumbs lead the attackers to the decoys. Decoys are similar to honeypots, but they are high interactions. They are actual VMs that the attackers can interact with. They can actually infect, but everything on that VM is recorded and generates alerts sent to us. We have so far used that product to catch 5 APTs at customer sites. And we have also released a community edition of our product. You can go to our website, download it right now, experiment with it. Let us know if you do. Enough about that. So what are we going to talk about here? I'm going to talk a little bit about writing honeypots, why we want to do that. I'm going to talk about different honeypot types, what makes a honeypot good, and a step-by-step on how to write them. And of course, I'm going to talk about Honeycomb itself. So the honeypot ecosystem, there are a lot of honeypots that exist today. You can check out this list. It's actually pretty cool. And many honeypots are not standard. There are some that, like Dionia, Curry, each one for a different purpose. Each one is specialized. You need to learn how to operate each one. And there are, of course, honeypot frameworks that are designed to assist you with deployment of honeypots. Some are very advanced. Our focus with Honeycomb is to create a library of different honeypots. We have started it once. It should make it easy to write new honeypots, to discover new honeypots, and from the other side, gain exposure for your honeypots, and to also get other people's honeypots. If you write honeypots, we provide you the infrastructure to do reporting, to install the honeypot, to implement low interaction honeypots, medium interaction, and even high interaction honeypots using Dockers. And it works. It's similar to pip install or apt-get. To get a list of possible honeypots, you just run honeycomb service list -r, and then say you want a honeypot for a printer that we have Xerox and HP. You do honeycomb service install HP Officejet. Oh, sorry. And then let's say you want syslog reporting. Then you configure the integration for syslog. Integration configure. You tell it to send on UDP to this address. Of course, it may be a different address on this port. And then you just run the honeypot with syslog. The nice thing about Honeycomb that it will work the same for any different honeypot you create. So if you want a different honeypot, say Xerox or web server or SSH honeypot, the configuration, running the honeypot, everything, all the steps will just be the same for the different honeypots. So it's a standardized interface. And now the question, probably a lot of you are familiar with honeypots. It helps to understand, before writing a honeypot, what is your goal? What do you want to achieve when you write a honeypot? So first, you might want to run a honeypot because you want to understand what attackers are doing today in the world. You want to see what attacks are prevalent. You want to understand if they're attacking, which services they are attacking. And if you know the services they are attacking, you might be interested in mapping the source IP addresses, maybe get IOCs for the attackers. You want to discover and fingerprint the vulnerabilities the attackers are using, maybe catch their payloads as well, and understand what they are targeting. So not just attacks on the world, but also attacks on yourself. So the attackers you can run honeypots just on a random IP in the world, but you can run honeypots that are somehow linked to your organization. For example, by using your own IP space or by placing breadcrumbs in the dark web for certain forums and so on, and see what's targeting them, and thereby understand what attackers are doing. And last, you can use same honeypots on your own internal network and catch the attackers while they are trying to scan your network for vulnerabilities. For instance, if you know that attackers, or not just attackers, even just some bots, or if you know that attackers are targeting security cameras, just Another thing that you can do is set up a security camera, honeypot for a security camera on your organizational network and wait till someone interacts with it. Nobody should interact with it. So if you see an interaction with that device, you know that it's probably someone being very curious running Nmap perhaps, or it's an actual attack. So the types of honeypots. I have a friend that says it's not the script that's fake, it's the honeypot that's fake. It's like it's not. There's a difference between a bad magician and an evil magician. So the script is real. Of course, what we're doing is fake. And the easiest thing to start with is just let's listen on a port and record everything that happens. The next thing is, okay, we're listening on a port. The next thing we can do is we can provide the correct answer of what the client is expecting to see. Just a banner. The next part is that we can interact and answer appropriately according to the protocol. And then we can, next step of complexity, we can implement the full protocol. And last, we may want to simulate what the operating system behind the protocol. So for example, if we have a honeypot that the purpose of which is to catch a directory traversal vulnerability, then you might want to simulate the files that the attacker might want to reach. So then you will not only need to implement the honeypot, the protocol, the vulnerability, but also the files behind the honeypot. Next step in complexity is to run the actual software in some kind of a container, Docker or LXC, and that way, and that makes it in some ways very easy. For example, if you want MongoDB, MySQL, databases are nice, but you can also do SSH. You can run the actual software, and then your honeypot is just to do logging, to get alerts, you just monitor the logs. And then every time someone connects to it, they are connecting to a container. It is less risky for you, but you can see everything that's going on. So that's an easy way to write a honeypot. The downside of it is that it is harder to make it vulnerable. You either need to get a vulnerable version of this particular service, or you need to write the vulnerability into it. The next step in complexity is, of course, doing the same but on an actual VM. Now, there is not a lot of difference from practical purposes between running it in a Docker and a VM. The VM just makes the separation more effective. So if you actually, for example, provide SSH access, actual SSH, it is better to run it in a VM rather than a Docker to make the separation between your actual host and the honeypot, so that if attackers are coming inside there, it will be harder for them to escape outside of the honeypot environment. So the next question, what makes a honeypot good or useful? So from an operational perspective, you want a honeypot to be easy to set up, and you want it also to be effective at reporting things that it catches. This is the definition of just making it work. But the next step you need to ask yourself when you are writing a honeypot, who am I trying to catch? Am I trying to catch a human being? So if that is the case, then I need to make, for example, if you're making a web interface of a printer, then you need to make the web interface look live and real and look good. But if you are trying to catch a machine, then you need to make the HTML behind it look realistic and similar to the original, say, printer web interface. So that if I'm an attacker scanning the network and I look for signatures of what I'm looking for, I will find it. So the UI might look exactly the same, but if I'm scanning for signatures, then I will not find it in that case. And of course, in some cases, you want to fool both. So this is more complex, but then you need to take into account both how it looks and how the technical behavior it looks like. So I wanted to show you how to write actual, real honeypots. So what we need for a honeypot? We need a mechanism for emitting alerts, essentially a way to send out. So just a function that will send alerts. So Honeycomb provides this. And it should be flexible enough to allow different fields, because some honeypots may report just source IP and protocol, But some honeypots can also report, hey, this is the command that the attacker ran. This is the type of your HTTP access the attacker attempted. And maybe there were different files to be accessed and so on. So you want to be flexible with different files. You need an easy way to start it up and shut it down. And last, you want an easy way to install it. Honeycomb, of course, gives you all of that. And before starting, we need to actually research the system that we are writing a honeypot for. So ideally, you should get a copy of the actual system. So if you are writing a honeypot for a router, it's best that you get the actual router, ideally next to you, but not necessarily, and research it and try to make sure that your honeypot duplicates the behavior of the router. If you don't have access, you can maybe borrow one from a friend, and I have friends that use Shodan to research existing machines. Also, it's very useful to get a legitimate client that you can experiment with and make sure that the behavior of the client with the actual server is identical to the behavior of the client with your honeypot. And last, if you are writing for a specific exploit, then you need ideally the vulnerable server, and also it really helps if you have a copy of the exploit that you can experiment with it. So this is why once, say, vulnerability is released, it is sometimes not enough to write a honeypot. You also want someone to implement the exploit so you can test it. And sometimes you will need to, before you start writing the honeypot, you may want to write the exploit yourself. So where you can get it, if it's open source, you can download it. You can borrow, as I said, from a friend, or you can use something like Shodan to find it online. I know people who do that. And getting the exploits, of course, there are places like ExploitDB and so on, or sometimes GitHub. And usually there will be links from the CVE database to the exploit. And so when you are writing a low interaction honeypot, one way to do it is to just start from scratch and write a script that does it from scratch. Another way is to get a library that does it for you, which is the easiest thing. So this is actually, I will show that to you later. I will show both of these approaches. But if you are writing something, say, I just want to write a banner, then just write a socket, use a socket server in Python, listen to incoming connections, and send out what you want. If you want something that is a web server, just use the Python web server. That's easy. And again, as I said, if you're trying to fool a human, you need to make the UI look realistic, and then make sure maybe get the actual HTML images, CSS from the actual server and just serve that. If you are trying to fool and make it look good, and if you are trying to fool a machine, then you need to make sure that the behavior is identical. So definitely test it with a client of this protocol. If you are writing from scratch, it is similar, but usually you need a socket server, and it's helpful to have the protocol reference, of course. So yes, so when writing for a particular exploit, it's useful to check with the actual exploit. You start with a regular server, and then run the exploit against it, run the exploit against the actual vulnerable server, compare the results, and then modify your code until the exploit works on your code. And sometimes, some exploits, for example, if they are exploits for SSH, the next step that they will do is they will try to do a ping back home, open a socket back home, or do a post to some URL. Of course, usually you don't want to simulate that behavior. It doesn't make a lot of sense, so there's not a lot you can do here. Ideally, you detect the actual usage of the vulnerability, but sometimes it is hard to do that, and then you detect just the behavior of the exploit. This is, for example, a problem that we had with, we wrote a honeypot for Mirai, and we wanted to detect specific Mirai usage. Now, Mirai just used, looked for relatively open security cameras. So in order to say, this is Mirai, all you need to do is have a few signatures of the steps that Mirai is doing, because the original Mirai code did a few steps, one after the other. So if you detect those steps, you can say, this is Mirai. So it's not always necessary to do very complex vulnerability simulations, but you can identify the behavior. So this is my example from Imri. And so, as I said, so we want to identify, so what Mirai did, it verified the telnet is open, and then it verified that the security camera was vulnerable. It sometimes brute forced passwords, and then it did the exploit. The exploit steps was infecting it, and of course there were different stages because Mirai had different components. Sometimes the addresses were passed from one component to another. So, but from our perspective, it doesn't necessarily matter. We can just create a honeypot and report on the first access that we see that matches those steps. And it helps because we also had Mirai code available and we could compile it. We could change it. We patched it to only attack our server. And we learned what it was sending to us, and we modified our code to accept it and make sure that it answered those specific requests. If we got stuck, we reviewed the Mirai code, and then we tested it again and again until both Mirai reported success and both our code said, hey, this is the signature for Mirai. And then we had a definite indication of Mirai, and we released that. The way it looks is like that. So we had the possible commands that we, if we had, for example, the PS command, we sent a particular response and something that Mirai was looking for. For example, if we had this command at the catdev.nippon, we sent this particular response, and so on. And we had pretty simple, straightforward box that simulates BusyBox, which is what Mirai was attacking. So for every command, if the command had start with BusyBox, we would look it up, and then we would just send the response for that particular command. Another example is with HP Officejet. So this was an exploit from 2017. It had arbitrary code execution, and there was a very nice exploit from exploit.db, which we used. And so you can see on Honeycomb, it's available on Honeycomb plugins. We had the code to, the way the code works. Essentially, it would be handle the commands in PGL, get the commands, and then respond to them according to what the client is expecting to get, or the exploit is expecting to get. Now, to write a high interaction honeypot, as opposed to these ones, the easiest thing is to run your server in a Docker, and then add a bit of code to the Docker that will monitor the logs and send them outside to your actual monitor. And for low importance events, just send a low importance alert. But for the actual interaction with your honeypot, the stuff that you're looking for example, successful login, then you will want to generate a high importance alert. An example, you can check out our Struts honeypot on our GitHub. And the way the honeypot looks like in Honeycomb is the following. So, and this is the actual code of the HP honeypot, at least the PGL part of it. So there's a server start. We need to implement a server start function. We need to implement the on server shutdown, and a test function so that you can test the code, and the alert. The alert is mostly implemented for us. We just need to use the underlying alert mechanism. So creating a honeypot is as simple as starting it up, shutting it down, and having a callback inside that will just call the alert function. That's it. Once you have that, you have a working honeypot that works with all the existing plugins that Honeycomb provides to you. The most recent example, which is the interesting one just from, I think, a week ago, a new exploit was released called, a new vulnerability was discovered called libSSH authentication bypass. So if you're not familiar with it, it's a bug in the state machine of libSSH. So if you have, it's the state machine of the server. Apparently, they did not implement the responses for all the possible states, and the client just sent a state that was actually a client state, told him authentication successful. And because they did not implement the transition, they just accepted it and skipped the authentication. So it's pretty silly, but it works effectively in essentially any server using libssh from that version, and you can test with the exploit, and you send authentication successful in the right way, you can get inside. So let's write a honeypot for that. The approach, let's create an SSH server using Paramico, which is a Python library for SSH. We will patch the server to detect the vulnerability, and also patch the server to look like libssh for vulnerability scanners, or general scanners. So I will want to show you a demo both of Honeycomb, how it works, and also for libssh. So I will close that. Let's start with Honeycomb. So I have this as a video, and the other one will be more live. So as you can see here, this is, we are installing Honeycomb framework just using pip. Very, very simple. This is starting from scratch, not doing anything. And the next step, you want to install the actual honeypot, and the first let's see which honeypots that we have available. So let's install the printer honeypot, the HP one. It's that simple. It's like pip install. Now what we're doing is let's install the integration. So we need to get the list of integrations. As you can see, today we have Cuckoo, Sandbox, Elasticsearch, just JSON files, MISP, uploading to S3, sending SMS, and syslog. So in this case, we'll just install syslog. It's easiest to demo with. And now we will actually configure the syslog integration, and the next step we will run the honeypot. So to configure syslog integration, we need to provide it with arguments, which protocol, and the port. So we will do just that, listen, and of course the server address. So the server is going to be here in this simple netcat instead of just using a complex syslog listener. And then all we need to do is just run the honeypot. We can do ---- integration or -i. OK, so we have the server here, and here we have the exploit. So if you see, this is just the source code of the exploit that I showed you before. And we are going to run it. And now you see the alert here. We have a critical alert or a HP path traversal. And in this case, we have the alerts coming out to syslog. And what I wanted to show is how easy it is just running a few commands. And just like pip install, you get a honeypot to you, and you can deploy it very easily outside. So the next thing I want to show is a demo for libssh. So libssh was released, the exploit was released last week. There are plenty of exploits. Nobody wrote a honeypot yet. So over the weekend, my colleague and I, we wrote a honeypot for libssh before coming here. So let's take a look at the code for that. So we have, this is the repository for Honeycomb, if you want to try it out. And this is Honeycomb plugins. We didn't yet merge to master, so we can check out the code. Actually, instead, this is where all the honeypots that we have reside. So we already have honeypots for Drupal, FTP, Intel MT, IPKM, Micros, and I have the source code open here. So let's make it easily readable. So same as before, if you want to create a honeypot from the Honeycomb side, you need to provide a way to start the server, a way to close it, and the reporting of alerts, and then you just use the underlying alert mechanism to send it outside. So if you use a MISP or a syslog integration, it will take those parameters and send them outside. You don't care. You don't need to implement all of that from scratch. And again, this is just for integration with Honeycomb. And from the server side, this is where we do the more complex work, but we don't need to care about all the other stuff. So we just need an easy way to start the server. So we have Python gives us a threading TCP server. We have a request handler for that. The request handler is the SSH request handler, which is actually running Paramico. What we did, we just almost copied one-to-one the sample for Paramico on how to set up a server. We had to fix a few things. So here is setting up the transport, and this we replaced. Instead of using the Paramico transport, we used our own. The difference is, so here is our transport. The difference is that we copied the run function from the Paramico transport and added code to detect the vulnerability. So this is the change. If we get, someone sends us the success, we just send out an alert. That's it. And once we have that, we have a honeypot that is able to detect the libSSH vulnerability. And it's as easy to get it. It's as easy as Honeycomb service list -r. And so originally I planned, hey, I'll just show you the code of the libSSH honeypot, and everyone say, hey, that's nice. But then I spoke with the very kind people from Deutsche Telekom that presented yesterday, and I showed them the libSSH honeypot, and they said, you know, if you want our feedback, you should run it. So I said, you know what? I worked last night, and what we did is we uploaded this honeypot to AWS, ran it here. So as you can see, it's running in the background. Honeycomb has a mode. This small -d here means it's running in the background as a daemon. And I also have the exploit here. And so we will run the exploit. And this is the response that we expect to get with this particular exploit. I just downloaded a ready exploit from the web. Now, the other part of what these kind of people said is that we should see the results of the honeypot. So I have prepared also, I set up misp.symmetria.com, a new MISP instance. Of course, sorry for that. And I hope that I have my password not in the clear here. Yay. Let's use this one. All right, so we have the alert that we wanted to see of the exploit. This is from right now. You have CVE SSH bypass. So this is the actual exploit working. The exploit essentially reported, hey, it worked. The honeypot detected it and sent out an alert to MISP. So you can see it working end to end. You can connect it to your own MISP. It's as easy as just running Honeycomb integration, configure MISP, and providing it with a key and a URL, and you can connect it to your own MISP. It's that easy. And not just that, we also wanted to make sure that other attackers would find it, of course, because I completed setting it up only this morning, so attackers have not yet found it. But just so you understand about the libSSH, so if you look for libSSH on Shodan, you will, so generally on Shodan, just libSSH, you will find around 6,000 results. Just on port 22, you will find this number. If you look specifically, even in Poland, you will find 17 servers. And this is not in Poland, this is on AWS in the US. And this particular one is the one that I set up. And I asked Jordan to scan it from scratch. And the important thing in the honeypot is this signature here. This allows us to be discovered by attackers. So in the next few days, we will see if attackers are actually scanning servers with it and maybe even trying to exploit it. So I think 10 minutes early. And this is it.